Hello, in this video, I will explain to you on how to solve this problem. A slide looping peak slides on a certain 35-degree slide in twice the time it would to take slide down a frictionless 35-degree slide. What is the coefficient of kinetic friction between the peak and the slide? Okay, because I don't have the picture of the peak and I only have the picture of the camel, let's just assume that this is a peak, right? And okay, we have slides here with the angle of 35 degrees. Now let's draw what is the force that is working on this peak here. And obviously we have its weight, right? So I will have the force by its weight here going down. Okay, and that will be Fw, the force by the weight, or that will equal to the mass times gravity. Here, okay, now because it will move to this x direction, right? This is the x direction. We need to project it into this x and also to the y direction for the purpose of calculating the friction, right? So here I will have this theta here, which is also the same as this one here. So theta is 35 degrees. So I will have theta here is also 35 degrees. And this here, I will have this force here of Fy, right? So I will have Fy. And here I will have the adjacent of the angle and hypotenuse. So I will have Fy here is equal to the Fw, but adjacent and hypotenuse is cosine, right? So I will have cosine of theta, which is cosine 35 degrees. Good. And here I will have this one here, which is the force in the x direction here. And because this is cosine, this is obviously sine, right? So I will have Fx here is equal to Fw sine of 35 degrees. And because this is frictionless, we can only see on the x direction is just this Fx here. So I can do analysis using Newton's second law here. Sigma Fx, the net force on the x direction, is equal to the mass times acceleration on the x direction. And the only working force in this one is this one here, which is Fw sine 35, right? So I'll have Fw sine 35 degrees. And that will equal to the mass times acceleration on the x direction. But then force by the weight is m times g, right? So I'll have mg sine 35 degrees, and that will equal to the mass times ax. And the mass here will cancel each other. So we will have the acceleration on the x direction here is g sine 35, which is 9.8, and then sine 35 degrees. And that will be, what is ax? Ax here is equal to 9.8 multiplied by sine of 35. And I will have 5.62. 5.62. And the unit here will be meter over squared second. This is the case where it is frictionless, right? So I think I need to write it here. So this is frictionless. Okay, but here we need to compare the time, right? So I'll have twice the time. Okay, so we need to take the time here. So what can we do? We can do kinematics, right? So I will have the distance here, x. The distance is the same, right, between frictionless and not frictionless. So I will have PO times t plus 1/2 the acceleration of the x here and multiplied by t squared. Okay, and assuming that it does not have initial push, this one will be 0, right? It starts from the rest. And so we will have our x here is equal to 1/2 and then multiplied by 5.62 and then t squared. Good. Now I will have 2x here is equal to 5.62 t squared. And then we will have our t here. Our t squared here is equal to 2x divided by 5.62. Or we can just write this as the time when it is frictionless, and that will equal to the square root of 2x divided by 5.62. Okay, and I think we need to save this here, right? So we will have to save this here. Okay, now let's do analysis when it has friction. Okay, let's clean up this. Okay, now we have the time when it is frictionless, right? And now we want the time with friction is twice the time with frictionless, right? So I'll have this is equal to 2 times t frictionless. Okay, frictionless, and we can just plug that in. So we'll have 2, and then this one will be multiplied by 2x and then divided by, I think we will have 5.62, right? So 5.62, and I think we can just go inside, right? So we'll have square root of, I think I will write 2 here as square root of 4, and that times 2x divided by 5.62, right? So we will have this here. So we'll have this square root here. I think I can rewrite this as 2x divided by 1 and divided by 4 multiplied by 5.62, right? So however, we have to remember that this is the acceleration when it is frictionless, right? So this is the acceleration when it is frictionless. So the acceleration with friction is all of this, right? So we will have this one here. So I will have the acceleration with friction here. The acceleration with friction is equal to 1/4. Okay, 1/4 multiplied by 5.62. Okay, now we will have this one here, 1/4 multiplied by 5.62, and that will be 1.41. Okay, I will have 1.41 meter over squared second, and this is our target, which is the acceleration with friction. Okay, now with friction we have this here. With friction I will have this force by the friction, right? And to calculate that, I will have to use mu k times n, but then n is the force that is pushed by the plane into the peak here. So this is n. Okay, and I think we need to do analysis here, right? So let's clean up our slide. Okay, we will need to do it on the y direction first. So I will have sigma Fy is equal to the mass of the peak times acceleration on the y direction. But the peak is not flying or the peak is not falling, right? So I will have this will equal to 0. There is no movement in the y direction. But then I will have this Fy here. So we will have the normal force on the positive direction and Fy on the negative direction. But Fy here is just Fw cosine theta. Fw cosine 35 degrees and that will equal to 0. So the normal force here, Fw is just mg, so I will have mg cosine 35 degrees. Good. And that is on the y direction. Now let's do it on the x direction. So I will have sigma fx. That will equal to the mass of the peak times acceleration on the x direction, but this time with friction here. And so on the forward direction, on the positive one, I will have fx. So we'll have fx and then minus the force of the friction. Okay. And that will equal to the mass multiplied by ax. Good. Now fx is Fw sine 35, or I can rewrite that as mg sine 35 degrees. Okay, and then ff is mu k times n. So I will have to write it mu k times n, but n is mg cosine 35. Okay, and that will equal to the mass of here, and then multiplied by a here. So I'll have 1.41. Good. Now we can divide all of sides by m. So I will have m cancelled out here. And then we will have mu k here. So I can isolate mu k here. So I will have g sine 35 degrees. And then minus 1.41. Okay. And that will equal to mu k and then g cosine 35 degrees. Good. And so we can isolate for mu k here. So we'll have g sine 35 degrees minus 1.41 and then divide that by g cosine of 35 degrees. Okay, and we can just plug the values here. Let's do that. So I will have g 9.8 and then multiplied by sine 35. Okay, good. And then minus 1.41. Good. And then divided by g 9.8 and then cosine 35 degrees. And I think we will get the numerical value here, which is 0.52. So I'll have 0.52 here. Okay, maybe 53, some numerical error may occur on this. So I will have the coefficient of mu k here is equal to 0.42. And I think that's all for this problem. Thank you for watching and see you in the next video. Bye bye.